Okay, here's the quiz review. These are two questions that are very similar to two of the questions on your quiz. There are 6 questions total. There's 5 questions similar to number 1. Actually, 2 of them are way easier, and then there's 3 like this one. One of them does have trig in it. Number 2, there's only one question where I'm asking you to find the second derivative. So if I were you, I would take the time to work on these problems right now on your own to see how far you get, or if you get it right, and then watch the rest of the video where I'm just going to do both problems. Okay, so hopefully by now you've actually tried doing both problems. So we're going to see how far you got. Please do try to do it on your own first. That's the purpose, and that's what's going to happen on the quiz anyway. Okay, so here we're just finding the derivative. This is implicit differentiation because there's both x's and y's. Remember, it's basic rules are being used. The only difference is whenever I take the derivative of y, or of a function with a y in it, I have to tack on that dy dx. It's like a chain rule. Okay, so to start off, x cubed, that's 3x squared, minus, now the 3x and the y, that is a product rule. So this is how I'm going to split it up. This will be u, this will be v, and I'll just leave the negative outside so not to get confused with it later. I can distribute. So I'm going to do that in there. And then equals 3y squared, but because I derived the function of y, I have to do the dy dx because I'm deriving with respect to x and not y. This dude right here, right? Okay. And then the derivative of negative 6 is just 0. Okay, so the 3x times y, I'm going to do the product rule. So I get u, which is 3x, times v prime. The derivative of y is 1, but dy dx, plus v, which is y, times u prime, which is just 3. Okay, so next line I'm going to distribute the negative and write everything in a friendlier way, right? Like the 3, I'd put it in front of the y. Okay, so 3x squared equals, sorry, getting ahead of myself, minus 3x dy dx minus 3y equals 3y squared dy dx. Okay, at this point, you're going to take every single term that has a dy dx and you're going to bring that to one side of the equation. Just to keep consistent, I would much rather bring everything with a dy dx to the left and then everything else to the right. You don't have to. You could leave the dy dx's on the right. But for consistency's sake, okay, so I'm going to move this over. And I know, you're like, but it's already there. I'm just going to do it. I'm moving that over to join the other dy dx. And then this is going to have to be moved as well, because they don't have dy dx's, so they'll be moved to the other side. Okay, so you get the idea. I'm not going to write all that stuff. Okay, so these will eventually, or essentially, cancel out. So I'll have negative 3x dy dx minus the 3y squared dy dx that I moved from the left, or from the right side. That's going to equal these, right? Negative 3x squared plus 3y. Okay, so next, isolate the dy dx. You need to get the dy dx alone. So in order to do that, both of these terms have a dy dx in common. So this is the common factor. So we're going to pull the dy dx's out. Right, so dy dx, and then in here is what I have left over. So negative 3x minus 3y squared. And that equals negative 3x squared plus 3y. Okay, next job in the isolation process is to totally get rid of the numbers that are with the dy dx, and that requires division. I'm going to divide this term away. And I'm going to divide it from both sides, right? Because that's what we do. That's how algebra do. It does this thing. So I'm going to divide this on this side, and I'm going to divide it on the other side. Great. So essentially that cancels out. And what I now have is dy dx totally and completely by itself equals. And it equals all of this. Okay, now, I see that they have the number 3 in common. And actually, if I wanted to, I could pull out a negative 3. So that's what I'm going to do. And because I want to simplify as much as I possibly can, hopefully without messing up. But you do want to simplify because you have to get practice in doing it for when you're taking the multiple choice part of the exam. They do simplify, and you need to be able to recognize or know how to simplify to that point. So I'm going to take out a negative 3 from the top, so that leaves a positive x squared and a negative y. Over, okay, a negative 3 from the bottom, and that leaves a positive x and, whew, I can't talk, a positive x and a positive y squared. Alright, so hopefully you see that the negative 3's will cancel out, right? Because that was the whole point. They're in common for both top and bottom, the denominator and the numerator. So finally the answer is just x squared minus y over x plus y squared. And that would be the simplified answer. Okay. Next on the agenda, number 2, I have to find dy dx, and then I have to find d2y over dx2. So the first and the second derivative. First derivative, really simple. So 6y squared, so that's 12y dy dx minus 10x equals 0. Isolate the dy dx, so dy dx equals positive 10x divided by 12y. So yes, I totally skipped steps, because to me this is a very simple equation, and you have 2 of these on the quiz. All I did was add the 10x to both sides, and then I divided the 12y. Right, I would simplify this. So dy dx equals, and then, okay, what number goes into both? So 2 goes into both of these numbers, right? 2 goes into 10, 5 times, and 2 goes into 12, 6 times. And there is my dy dx. Now, in order to do the second derivative, let me move this over. In order to do the second derivative, what you do is you derive the first derivative. Well, the first derivative is a fraction, so we're going to use quotient rule. So d2y over dx squared, or 2, equals. Alright, so this is a u over v. So I have to do quotient rule. So that's v times u prime minus u times v prime. So that's 6 dy dx. All over low times low, right? Low d high minus high d low over low times low. So that's 6y, the whole quantity is squared. Okay, so simplify a little. The 6 and the 5, that's 30y. The 5 and the 6, that's also 30, but x. And then dy dx, I know what dy dx is. You remember? Dy dx is over here. It is 5x over 6y. So I need to plug that in. 5x over 6y. Okay. And then all of this was over 6y squared, which if I do actually, simplify that, it's 6 squared and y squared. So 36 y squared. I wonder how many of you are just going to write 6y squared. That would be wrong. Okay. Um, so now I've got fractions inside fractions. No bueno. So I need to do stuff, right? I always do this. I always put this right next to the top number. Okay, so I'm going to work with the numerator right now. In the numerator, there is a fraction where the denominator is 6y. But let me get rid of the 6 because 6 goes into 6 one time, and then 6 goes into 30 5 times. So I got rid of the 6. Yay. Now y. I got to do something about that y. What I'm going to do is I'm going to give the other term, the term on the left, I'm going to give it the same denominator, right? This is just all algebra. And we do that by multiplying it by y over y. Okay, so let me write what I have now on the next line. So I have 30 y squared minus 5 times 5 is 25. X times x is x squared. And now they're both over y because now they have the same denominator. And this is just the numerator, right? And this is all over 36y squared. Okay, I still have a fraction inside of a fraction. So the way you divide fractions is you're actually going to multiply by the reciprocal of the second fraction. Or in this case, I'm going to multiply by the reciprocal of the denominator, which would be 1 over 36y squared. And then I no longer need this part. Okay, so 30y squared minus 25x squared over, and then the y and then 36y squared, that becomes 36y cubed. And that's basically it. Just that when you get to this point in implicit differentiation, your job is to look back at what was my original equation. Because if you can find the original equation somewhere in your answer, then you can replace stuff. For example, the original equation was 6y squared minus 5x squared, and it equaled 3. Okay, well here I have 30y squared, so this is the same, minus is the same, and x squared is the same. The only thing that changed are the coefficients. Well, 30 and 25, can I make those look like 6 and 5? And hopefully your brain is like, oh yes, because 30 divided by 6 is 5, and 25 divided by 5 is 5. So, this is what I'm talking about. 30 and 25, they have a common factor. It is the number 5. So let me pull out that 5. I end up with 6y squared minus 5x squared. And then the bottom just stays how it is for right now. Okay, now, the whole purpose of that was this stuff right here. That is the original equation. Go back up, 6y squared minus 5x squared. So, looky. The original equation was 6y squared minus 5x squared. And it equaled 3. So I can use substitution. I can remove the original equation and replace it with a 3. Okay, so 5 times 3 over 36y cubed. Didn't that clean that up just beautifully? I mean, it's a much simpler equation now. So 5 times 3, that's 15 over 36y cubed. And yes, I can simplify that, right? Because 3 goes into both numbers. 3 goes into 15. 5 times, and 3 goes into 36 12 times. And there's my answer. Okay? The second derivative is 5 over 12y cubed. Yes, there's one exactly like this on the quiz. You have to acknowledge or recognize, ooh, the original equation is in there. I can replace it with a much simpler number. Okay, now, next class, you're going to take the quiz. There are 6 questions. You're going to work on the review packet that I gave you in class. Test on Thursday. It is on Chapter 3, Part B, which is 3.5 to 3.9. Okay, that is what Chapter 3, Part B is on. All right.